Everyone, welcome to this session number 357. And today I will continue with this project that yesterday I didn't complete. And basically is the lowest common ancestor of the binary tree 2. In this case, we need search two elements. The common ancestor of the two possible elements, but in this case it's possible that this element doesn't exist. Yeah, for example here the P exists but the Q and the Q, yeah, but in this case for example the P exists but the Q doesn't exist, means that don't have any common ancestor, you know. And in this case means that only one of both elements are null, only one, yeah. Both can't be null because basically all are different, yeah. Okay, for this I was trying to reuse the another solution, the solution of the lowest common ancestor of binary 3-4, but I think that here I need to use another thing to solve it. And well, in this case, for example, this return null, but where this is null, yeah, because basically here is go to the left, go to the left. I think that I can use another function that return on the final this and the final apply this validation. Yeah, for example, private find lowest common ancestor, very similar to this. Even I can copy and replace by this. Okay, and in this case remove this, and here is this, here is this, and no, because in this case this search to the left side, yeah, here, and basically search the common ancestor of this element, and for example only find the number 5, return the number 5, and now for the right side search the common ancestor of this case, for example don't find anything, return null, and is 5 and null, means that should be returned null. But in the case, for example, that in this side appear all the elements, for example 5, and do you imagine the other is Q, in this case the common ancestor of both are I think that I can use the lowest common ancestor, this, only one time with this, and tree node P node it's equal null, and Q node it's equal null, and if tree node lowest common ancestor it's equal this. If this is different to no, here is if p node it's different to null and q node it's different to null, means that if exists in the tree, return lowest common ancestor. In other case, return null. And obviously here I need to validate if here, for example, where happened this, basically we need to validate which case if root it's equal p. The first is validate that this is different to null and root it's equal p. Basically p node it's equal root. Yeah. Else if here is only for validate that where appear the first or the second, well, it doesn't matter. Q, here is Q node it's equal root. Well, the value is doesn't matter. It's only should only need to have a different value than null. Sorry, and that's it. Okay, here find less common ancestor. Yeah, sure. Tree node. What? Why? Let me copy this. Okay, I still having the T0. Why? I am put here the value. Weird. Why this never end? Why? This receive the root that is 3 and ask this is equal to the p? No? Okay, now go to the left with these values. This is equal to p. Yeah, in this case p is different to null. And root is equal to p. Means that p node is this. Got it. And return the node. Okay, here return the L. Should we have a 5? Okay, now come back to this and now go to the right side and is 1. In this case, yeah, is 1 and is the Q, means that return this. Still running in this line, but why? Ah, sure. Yeah, it's for this because I am calling the other. Ah, yeah. Okay. Okay. Yeah, but in this case, find common over ancestor, and here is I I didn't use the. In this case, it's null and it's 5. Why? The second. You know what? Here, I will change for a simple counter. The year counter. It's equal 0 and increase plus plus in when happen this or happen this, but pp and q counter plus plus. And here is basically if counter is equal to, should be 2 because is in other case return null. I am returning null, but the spec 5 means that this ancestor. For be sure. Okay. Now this is the 5 and 4. Why don't return the 5? Let me check. In this case is the test 2 and here is the test 2. I will valid lowest common ancestor result is 5, but counter only have 1. What is the value of counter? It's for the counter, but why? Yeah, sure. Yeah, because in any moment the other is reached. Then because for example when reach this, the first element is not continue with the others. Yeah, return to this and now go to the other side. I think that this approach doesn't work here because I'm not sure that exists. In this case, I can be sure that exists if I found this. Oh, maybe. Yeah, because for example, if I am searching the 4 and I stop here, I can cross and don't continue with this for this reason. This is different, I think. Let me check. this. Now I need to transversal all the tree for be sure that exists the number. That is a problem with this, that we don't know if exists or doesn't exist. I think one possible solution, but is awful, is have this code and another that transversal all the tree and only validate if appear the two elements. But I think that is not a good approach. Works because in this way we have the two answer for be true should be contains the two elements, yeah, and obviously the recursive function return the common parent, the possible common parent, and that's it. But in this case, I think again it's an awful solution. Now p, oh my gosh, this is small. Where here. Okay, much better. Okay, we start here. Yeah, p is equal 5, q is equal 4. In this case, I think that I can transversal, for example here, or I found this, and the current, no, the lowest common ancestor it's equal to the first element that I found. In this case, go to this, is no, is this, no, is this, no, is this, yeah. In this case is 4, means that this is the common ancestor, the first that appeared. But now imagine that the p is equal 7, q is equal 1, no, 8. In this case, I start here. This is the p o q, now go to the left. This is p o q, now go to the left. P o q, now go to the right. P o q, now go to the left. P o q, yeah, is p, it's equal 7. Yeah, right now this is the lowest common ancestor. Now go to the right is q, no, come back. Go to the right is q, no, come back. It's a q, yeah. In this case, we are trying to say that the 7 is the lowest common ancestor of the 0, but it's not true because the common ancestor is 3. Okay, it's not the first that appeared. Let me think. If I start here, and we need not to the common ancestor is this. So no, is this common ancestor? No, is this common ancestor? No, is this common ancestor? Yeah. In this case, this return the 7, and in this case return the 0. The common ancestor is this, but in the case that q is equal, for example, 6 is this and this, I think that I start here. This is a common ancestor. Is one of these elements? No. 5 is equal this? No. 6 is equal this? Yeah. In this case, this return the node that is 6. Go to the right. This is equal 7? No. This is equal 7? Yeah. Return in the left the 7. Return to the left the 7. In this case, we have that the common, where both elements are different than null. This is the common ancestor. Do you see? Again, we have these elements and we start here. This is the common ancestor of this. Is one of these elements? No. 5 is equal to this? No. 6 is equal to this? Yeah. In this case, this, where are equal, return the value. In this case is 6. Then don't have more. Now go to this. This element is equal this? No. This element is equal this? Yeah. Means that return this. This is different to this? Yeah. Return null. In this case, we need to return the element that is not null. In this case is 7, where appear the 3 elements, should be return this node, because this is the answer. Now for this, I will clear this and I'm so sorry. Let me check what happened when the q is where this it's equal 3. P is equal 3. Yeah. Return the 3. Go to the left. It's equal this. No. Go to the left. Okay. Let me check because I have the dou here. What happened? Every node or every iteration should be return one value. That this value is possible to be null or a node. In this case, for example, p it's equal 3. Yes. In this case, this should return the 3. And I'm trying to imagine the function. In this case, receive the node. Receive the node, the q, and the p and q, where are equal. I need return. No, but I am doing the similar. To the other approach. Yeah, I don't need to stop these values. I think that in this case it should be we start in the 3 it's equal one of these elements, it's equal 3. And what is this? We have the common ancestor as a 3. Now go to the next, is equal the 6. Now go to the next, is equal 6. Yeah, because it's 6. Now in this case, I don't know. Maybe 3, 5, 6, 2, 7, 4. But if the P is the first element, I think that yeah, it's transversal all the 3. Okay, it's transversal all the 3 and save the reference. Thank you. I don't know. Okay, if I start here and P is equal this, I need to mark the P it's equal 3 and go to the next. This is equal one of these elements. No, this is equal to one of these elements. Yeah, is 6. But in this case we know that are in this side, but what happened where Q is equal 0 and P is equal 6. In this case the first that appear is the 6, P is equal 6, and the other is the 0, P is equal 0. This is not the ancestor of this. I'm not sure if here, and even in the constraints mention without checking the node exists. P it's equal 5, no, it's equal Q it's equal 0. In this case, start in the first node, that is 3 is equal of this, now go to the left. 5 is equal this, now go to the left. 6 equal this, now go to the right. 2 is equal this, yeah, it's equal P. It means that I can again I have this idea to have this list with the previous parents, like for example the parent of this doesn't exist, the parent of this is 3 and 5, 3 and 5, 3, 5 and 2, sorry, 3, 5 and 2, and basically where I found both is try to searching the intersection between this and this, for example, that in this case is a tree. Mm. Yeah, it's my only solution that I have right now. What another solution? Yeah, I think, and it's only check. Uh-huh. Well, it's my only solution that I have in this moment. In this case is apply a DFS. In this case, DFS receive these elements, and we need to hash set. Come on, as a string. No, integer. Set one it's equal new hash set. Okay, but this is here. It's 2. Here is 2. Yeah, and we apply this. Now this DFS is a simple transversal. No, public. But in this case you can find it without checking node existence. Yeah, I think that with this private void DFS, this well, this is node. If node is equal null, return node. Yeah, and now the next that if p it's no node it's equal p. Here I need it's equal p. When find this element, flag 1, flag 2, and where node it's equal this, flag it's equal false, and here is else if flag it's equal true is set dot add, in this case not val, and that's it. we need to validate the q flag 2 flag 2 flag 1 flag 1 and here is dfs dot node dot left p and q, and it's the same in this side, but with the right, and now I have this. Mm-hmm. Now having this, I have two lists and I need transversal one. I just said Java. It's with while and has next. Oh no, I can transversal this way. Okay, 4. Oh, but I need to start for the last. Transversal. Now is this. I'm sorry. Modify that at link list. No. No, because start for the first, starting the first, starting the first, the first. Java. Add. Okay, here I think 2, 3, 2, 4. It's 2. Okay, I think that I can use the retain all. I didn't know that exists this function, but I think that works. Is set one dot retains all, set 2 in. But in this case this return the value, and I need return. Okay, means that I need save here the tree node instead the simple integer. Uh-huh. Uh-huh. In this case, val result is equal this val. Tree node result is equal this, and if result is equal null, return null, other case return result. What? Where here? Set 1, set 2. No, they return the intersections, but I need it's the same. I need the last. Or I can transversal and replace the element. Yeah, here I can transversal, then tree node and double point set 1 and tree node result is equal null. Yeah, and here is result, and I need ask if set2 dot contains n, result is equal n. Is set 1, set 2. Return null, and this return null too. Why? This left, right. Well, I'm not sure, but I need to go. But thanks for following this transmission, and I hope see you in the next. Bye bye.